Hello everyone, I'm Nikita from Galileosky, and today I want to provide a webinar. The subject will be geofences. I will tell what is geofences in general, how you can create geofences, what type of geofences exist. I will tell how to avoid common mistakes. Before we start, some information. The duration of our webinar would be about 30 minutes. Depends on you, on your questions, and of course depends on me. Depends on the speed of my speech. We will send the record of this video to the email which you used to register on this webinar. Then we will publish it on our YouTube channel, and also we will share all the useful links which I'll put during the webinar inside the chat. During the presentation, you can type your questions in chat, and in the end, I will answer. Before we start, I want to make a short announcement. The first point is, please subscribe to our new made WhatsApp chat. You can use this QR code to do it. With this chat, you can stay tuned to the latest news from our company and the latest news from the world of telematics in general. The second point of announcement is, again, I want to invite you, please join our YouTube channel. Especially, I want to emphasize the playlist about Configurator. Configurator is a special software to configure our devices. You can download the latest version from our website. I will share you the link in chat. We recommend to use the most modern version of Configurator. It will allow you to use the latest features of our devices. The plan of our webinar is like this. At the start, I will tell about what is geofences in general, what type of geofences exist. Then I will tell about methods which you can use to create geofences and then to operate with them inside an easy logic. First method will be creation of geofences inside the easy logic and scripting language. The second method will be creation of KML files. Then I will show how to create, how to download them to the device memory, and how to work with them. And in the end of the webinar, it will be a questions and answers session. So let's start. What is geofences in general? Geofences are the special areas on the map which can help you to control the movement of your vehicle or your asset. The idea is quite simple. You can draw it right on the map, or you can create the borders of geofence inside the algorithm and then determine if the device inside the geofence, for example, you can receive the flag and then implement some logic. The most common example of such logic is overspeeding. If the device have overspeeding in some precise geofence, you will make, for example, notifications or other actions, up to you. There are not a lot of types of geofences. The most common are round geofences with the shape of circle and polygonal geofences. There are huge amount of polygons, of course. On this slide, you can see on the first picture is the polygon with 8 points. On the second picture, you can see polyline. Yes, polyline is also a kind of polygon. Okay. What ways to operate with geofences and what ways to create them exist. First is to create geofence, to describe it right inside the easy logic, and then to implement the algorithm based on it. The second is to create KML file in some special software, for example, Google Earth or Violon, and etc. Up to you which is convenient. You can use every of them. First method is convenient, is compatible to use with square types of polygons and round type of geofences. Pay attention. If you want to create polygon inside an easy logic, you only can create square. The second method is compatible to polygonal type, only polygonal. You can't create round geofences inside inside your KML file. Of course, you can do it, but our firmware will not recognize it. It's one of the common mistakes when, for example, some client create a KML file with a huge amount of geofences. It is correct, it works somewhere else, but then he put this file inside the Galileosky device, and it does not work. And the reason could be that there are not only polygonal geofences, but few round geofences. So you can use only polygonal geofences when you create your KML files which you want to use inside the Galileosky device. Let's go to the first method, how to create geofence inside the easy logic. Starting from the square type. In this algorithm on the screen, you can see an example. I guess it's better to show right inside the configurator application. I have already installed configurator on my PC. We just need to open Easy Logic tab. Then, in my case, I already opened an example. In your case, of course, you need to create new one. What we need to do when we want to describe the square inside the easy logic. Firstly, we need to define 2 points of this square. For example, lower left corner of this square and upper right corner of this square. Then we need to define coordinates of these points. For example, here we use 4 blocks, 4 conditions, where we compare our current coordinates with longitude of latitudes of these 2 points of our square. First 2 blocks comparing current coordinates with latitude of the first point of the square. In this case, we use variable latitude, which is previously predefined inside an easy logic. You don't need to create it manually, you just need to choose it from the navigation tab. And this variable pulls data right from the GPS unit of the device. And then you need to compare it to your coordinate. For example, if you have latitude 56 degrees, you need to put inside this variable the value 56 and 6 zeros, because it is a requirement for this variable. You can put there only 8 digits int. It is true for all these conditions, of course. So here we compare latitude, longitude of the first point of the square, then latitude and longitude of the second point of the square. When all the conditions are true, we understand that our current coordinates are inside our geofence. And then we can implement some logic. The logic is pretty simple. We'll detect overspeeding. Again, we use a condition. We compare current speed of the device the variable speed is predefined inside the easy logic. You just need to choose it here. You can find it here, somewhere here. I already found it. And we compare current speed with the speed limit, which you can set manually. Here the speed limit is 60, maybe kilometers per hour. When this condition is true, we will open the output 0 of the device. We can connect, for example, LED light or buzzer to this output, and when we detect overspeeding, your driver will receive the notification. The light will be turned on or buzzer will make sound. If we are not inside the geofence, no signal in the track. So that was about how to create square geofence. Now go forward. How to create round geofence inside the easy logic. Again, it's better to show right inside the configurator. Algorithm starts from the device start, then we use delay to give the device time to initialize all the units. The logic itself is absolutely the same as in previous one. We will detect overspeeding and then open the output of the device, and they then force the buzzer to make sound or something like this. Also, I want to say that these algorithms are only, for example, just to show the main idea. It is very simple, and these algorithms are not very optimized. Of course, it's just for example. You can create much more complicated and optimized logic, of course. So, go back to our algorithm. What we have to do? We need to define the center of the circle. We need to define coordinates of the center of the circle. We need to create variable gzone latitude. Also, the coordinates which we put here should be 8-digit int. For example, in this case, our real coordinate 57 degrees, but we put here this digit. Then we need to define longitude and, of course, radius of our circle. Radius should be set in centimeters. Then the main difference of this algorithm. To understand, to determine if the device inside the geofence, we will use block script. I will show what is inside this block. This code example is inside the block script in easy logic. We create 3 variables here, which pulls data from previously created in block scheme variables, latitude, longitude, and radius. And then we use predefined inside the scripting language function in zone. You don't need to create it. You just can use this function. I will put this information in chat right now. The requirements and the function itself. Okay, you have it in chat. So, what's going on here? The in-zone function will return us -1 if the device outside the geofence. Oh, sorry, I confused a little bit. It will return 0 if the device outside the geofence, and it will return 1 if the device inside the geofence. Then we write this value inside the global variable myInZone, and then we can use it in our easy logic algorithm. Here. So firstly, we'll detect overspeeding by using the predefined variable speed, which pulls data from GPS unit of the device. Compare current speed to your manually set speed limit. Here it is 50 kilometers per hour. Then we'll go to our global variable G in zone, and when the device in zone, we will open the output and the buzzer will make sound. So, okay, that was all about the first method, when we can create geofences inside the easy logic algorithm, and in case of round geofence in scripting language too. Then we can go to the second one. First one was convenient when you don't need to create a huge amount of geofences, for example 2 or 3. Okay, it is convenient. But when you need to create a lot of geofences, it's hard to change manually all the variables inside the algorithm. And of course, it's better to use some other approach. And the second method is this approach. We can create KML files. This functionality is available on devices Galileosky 10 series, 7X, 7.0, and base block. There are few requirements. You can't create the polygonal geofence with more than 2000 points. And again, I want to notice this method is only compatible to polygonal geofence. You can't use round geofences here, only polygons. So polygons with not more than 2000 points. Maximum number of geofences which you can store on board of the device is up to 1 million. This feature appeared on the firmware 44.2 and higher versions. The polyline could not be wider than 50 meters. And two, the most valuable points, the name of the KML file must strictly be zones.kml, and the folder name where you will put this KML file on board of the device should be named Geofences. Only these two names. You can't use another names because our firmware will not recognize geofences. It is one of the common mistakes. As I promised in the start of the webinar, I will show some example of common mistakes, and we need to avoid them in future. So pay attention to this point. Then, starting from firmware 23.7 for Galileosky 7 for base block Iridium, starting from firmware 24.7 for 7X devices, and starting from firmware 1 for Galileosky 10 devices, our developers added the killer feature of our devices. I don't know about other manufacturers, but I'm not sure that a lot of them have such feature. Our developers added the opportunity to put 4 parameters inside the name of geofence, and then use them inside an easy logic. I will show how to do it, but now I will put the syntax of the name with parameters in chat. Okay, information in chat. Then we can start. I will show my screen now. How to create KML file. How to create geofences in KML file. Okay, let's clear it. Okay, delete. I will use Google Earth application, and as I already said before, you can use another one which is convenient to you. There are a lot of such kind of geofences. On this screen, we can see the map, the building. This building is our home. It's our office. It's the office of Galileosky company, and I am right in the center right now at the moment. Let's create one geofence here around the office. Let's choose polygon. Okay. Now we need to name it. Sorry. Office. Then we will use our syntax to put there one parameter. For example, 60. It would be speed limit. And then the syntax is like this: name, then colon, then parameter, and then 3 semicolons. We need to put semicolons because we can use 4 parameters, but in our case, these parameters are empty. But we still need to use this syntax to make our firmware information correct information. When you use only name without parameters, you don't need to use colon and semicolons, of course. Okay, we have one geofence with parameters. Then let's create some random, okay, untitled polygon, and for example, polyline. Polyline is convenient when you want to mark some street. Like this. For example, I want to control the movement of my track only here on this street. Untitled path. Okay. Now we have 3 geofences, one geofence with parameters. Then we need to save. Save. Choose KML. And then, I hope you remember, I noticed before, we need to name this file zones.kml. Only zones. Okay, I already have such file, but I will replace it. The file is created. Now we need to put this file inside the device. What we have to do to make it possible? Firstly, we need to send command msd1 from our configurator, from the tab commands in our configurator, to unlock the memory of the device. Let's do it. msd1 response. Okay. Command recognized. Then I will use a file manager named WinCSP. It is pretty simple and convenient. You can use another one which allows you to work with such feature. But if you want to use standard instrument in Windows, it will not work. So I recommend to use file manager. Here we need to choose our storage, our device storage. In my case, this one. Then we need to delete it. Okay, wait a sec. Excuse me. Need to reboot this application. Okay. It is in the left window, the storage of our device. Delete. Okay. Now, it is the storage of device. Here is, in the right window, our file zones. We need to create directory with the name Geofences. It must be strictly Geofences. Hope you remember. Done. And then we just need to copy the file. Okay. File is there. Yes. Check. There. But in the folder Geofences, now is only zones.kml. Let's reboot the device. After the reboot, we will check again the folder Geofences and we'll see what's inside the folder. The firmware should create the necessary service files automatically. Wait a second. Okay. Device was rebooted. Now let's check again. Storage. Sorry. Wait. Okay. We are inside the folder Geofences, and now here is not only zones.kml file, but 3 service files. The firmware of the device need these files to handle KML correctly. Now everything is okay. The firmware of the device will automatically handle the file and put the flag inside the predefined in easy logic variable geofence, the determination if the device inside the geofence or not. It will return us. I will show. It will return us. Okay. This variable geofence, it will return us -1 if our vehicle outside the geofence, and will return the number of this geofence if the device inside some precise geofence. So in this algorithm, we can see how we can implement the logic based on KML file. The logic is also pretty simple. It is the same as in previous 2 algorithms. We detect overspeeding here, and if we have overspeeding, we open the output 0 and make your buzzer buzz. Like in previous algorithms, device start, delay, then we use predefined variable geofence, which pulls data from the firmware and KML files, compare it to 0. If we are inside some geofence, we'll go to the second condition, where we compare current speed from GPS sensor to the property 1. You remember that when we created the first geofence around our office, I added there one parameter. It was a speed limit, 60 kilometers per hour. And in this case, we don't need to set this limit manually inside an easy logic. We just can pull this data from GeoZone property 1. We have 4 predefined variables in easy logic: GeoZone property 1, 2, 3, and 4. In this case, we use 1, but of course, you can use more than 1. For example, you can create 2 branches of the algorithm and set speed limit 40 kilometers per hour to the first branch and 80 kilometers to the second branch. And when the condition is true by the first branch, we'll open output 0, and the driver will receive notification by the LED light. But when the overspeeding is more significant, for example, more than 80 kilometers per hour, we will open the output not 0 but output 1, which would be connected to buzzer, and the driver will receive an awful sound, and it will force him to stop. Of course, as I already said, this is just an example. You can create much more complicated logic. and not only with overspeeding. You can use another logic, whatever you want. Okay, that was all about creation of KML files. Now, I want to make one more note. It is not a mistake, but it is a valuable point. When our developers added the feature of 1 million geofences inside the device, in terms of KML files, of course, the structure of service files was changed. And then a lot of our clients faced to the issue when they updated from the 38, for example, firmware to the 44.02, and the geofences stopped to work properly. But before it was pretty okay for few years, for example, and they didn't know what to do. The problem was in the structure of service files. How you can avoid it? After your device was updated, when update was major, from 38 to 44, or maybe in future you'll have the same, maybe the structure of service files would be changed again. When you update your device by major update, you need to clear hash file. How you can do it? You just can send the command to the command tab in configurator. The syntax is here. I will also put it in chat. Okay. So now that is all that I wanted to say. I guess this information was useful. Now we can go to the questions. Okay, let's check the chat. Now I can see the question from Lucas. Hi, Lucas. Nice to see you here. The question is there any way to upload KML files remotely? Yes, of course, we can do it. It is a little bit outside the box of today's subject, but we have a feature named WebDAV. You can use it. It's some kind of cloud technology. You just can synchronize your files in your cloud storage with the storage of the device remotely. Now I will share the link in chat. Wait a little bit, I need to find it. Okay. Here. You can study this manual, and if you have any questions, you can always text to our support, or maybe if you have chat with engineers or with managers, you can ask us, and of course we will help you with details without any doubts. Okay, looks that there are no any questions, so that is all for today. Thank you guys for attention. Thank you for your time. For us, it's very important when clients want to listen to us, to listen to our features, some information about our features. And the great reward would be if you implement interesting and complicated projects based on our solutions. Have a nice day. Bye-bye. See you later.